Alrighty, so welcome back to episode 9 already. We're flying it. Today was a spectacular day in Ireland. Some of you know, I live in the west of Ireland. So I took out the bike and travelled north up to Achill Island. Now, as some of you may know, the Banshees of Inisheer was filmed there, so it was a nice spot. And I met a fellow biker along the way. Now, as I said before, I have no interest in bikes at all. I just happen to own a bike. I was at a meeting, I think, 7 years ago in San Fran. And when I came out of the meeting, I saw a BMW Boxer bike outside, and I just was having a smoke, and I sat on it and I said, right, I have to have one of these. So your man came out after the meeting, and I think he worked for, was it Beats or L'Oreal, or I can't remember, but what the meeting was about. But we chatted about the bike, and I just fell in love. So I flew home, the bike was in my head, and I said, right, I'm going to buy one. But I didn't, and I think it was like 5 or 6 years later, I bought a BMW bike, and it's just been amazing, you know. But the guy was talking about, you know, he had a XR CX 1000 at home, and I was like, all right, okay, that's cool. I have no idea like about different models. I just have my own bike, and I like it. But yeah, fabulous day. So getting back to what we're about. So in this video, which is episode 9, which I will probably have to stop saying soon, because I have to check back what was the last video, like episode 8, right? This is 9. So in time, I'll probably just stop saying that and just name them when I'm editing the video. But it just makes it handy for me to look back and recall what the last one was or what we're following on from. But in this video, I'm going to do a bit of a talk on Formula 1 engine crankshaft oiling. So as you can see there on the screen, let me just check there's no glare. No, we're good to go. So this is a partial model of the Formula 1 Cosworth TJ engine, which is the V10 on my own engine. Now I drew this engine in CAD. Now this isn't the CAD of the engine. This is what I'd call a sandbox model of the CAD. Now sometimes I get asked by colleges or by engineering companies or by whoever to send on various parts of engines. Now that doesn't mean that I'm going to send on parts of engines to subscribers or to viewers. I'm not interested at all in selling files of engines, step files, cross sections. I don't do that. I have done in the past to a select few, but this model isn't for sale. Number one, because there's probably about 4,000 hours in building this model. From my own engine, which involved, measuring, 3D scanning, CMM, which would be coordinate measurement. So it's not a viable thing to start selling files of this engine, but it is all correct. But this engine here, which you see in front of you, is a sandbox model, which is one I send out. It's a saved file, not the exact file. It's a saved file I send out to colleges, as mentioned, for them to look at, and which I can edit or change. Then it gets saved as, so it can be a bit of a mess at times when it comes back to me or when I view it again. Again, this is Fusion 360, lovely software if you're starting off, as I mentioned. Absolutely terrible software for an assembly like this. And hopefully you won't see it stall or crash in this video. So I'm going to be fairly easy on it, but again, shocking bad software for huge assemblies like this. I mean, this engine has, I can't remember, probably 10,000 parts when they're all turned on. Now this is a sandbox model, as mentioned, so it hasn't got as many parts turned on or saved in this file, which is probably for the best, because it would just crash. Now none of these, as you can see here, are named. There's some of them named, which is, I think the last place this went to was college, I think in, was it Germany? I'm not sure. But the main ones is they wanted to see where the heads and the sump girdle, the block, and the exhaust. So there's some parts on there and some parts not active. So if you're wondering that some parts look weird on the model as I go through this video, it's weird because it's been saved, or it's been edited, or it's not a perfect model. But I do have a perfect model, thankfully. But I won't be sharing that for any fee or any barter system, anything like that. It's just not going to happen. So don't ask if you're going to comment on the video. Now, just one more thing before I move on. I know I've said it before in the community update section, the post section on this video. I've got a huge amount of new subscribers, which is absolutely fantastic. Now, some of them, I think I've deleted about 35 today when I was out on the road, just because they become high. Now, I'm not up to speed too much on YouTube. I watch a lot of it. I watch, some of the famous channels, and inverted commas. But if a comment is posted, for some reason it becomes a highlighted comment, and some of those highlighted comments are not good, so I just delete them. Now, I'm well used to the internet, and I've been writing articles on the internet and magazines for the last 15 years, I think, on Formula 1. But some of them, if they become highlighted, they stay there at the top, and I just have to delete them. Like, it's not, if I was reading, just going by a video, a 45-minute long video on the comments, and if I read the top comment, I probably wouldn't watch the video because of that comment, but that comment can sometimes be not true at all. Just one or two examples before I move on and bore you to death with the YouTube part of this video. Like, there was one guy that said, no offense to you, man, like, if we were in a pub for a night, I'd probably talk to him all night long about ships. But he said on the pneumatic valve video that this is old technology, nothing new here. The valve return has been around for, I don't know what he said, 50 years, with tugboat diesel engine valve return, pneumatic return, which is fair enough. But materials and engines have been around for a long time. So is air and pressures, pneumatics, all that. There's a big difference between a Formula 1 engine and a tugboat, which probably has its maximum power at, I don't know what, 900 RPM, which would be the valve chest. The valves will be reciprocating at about 960, about 9.5 times a second, compared to a Formula 1 engine, which would be reciprocating at probably 17 times a second. Plus, the tugboat weighs, I have no idea, like 50 tons. A Formula 1 engine weighs 115 kgs. So all those sort of comments will get binned, as will comments saying that, get to the point, there's nothing, there was no end point to this video. There isn't, no. As I said in the comment section or in the community section, if you want an end point, go watch TikTok or watch Netflix or watch a film. This isn't about tuning your Ford Escort. This is cutting edge technology which hasn't been seen before, with 15 years of Formula 1 experience behind it and mechanical engineering experience. So just, if you have nothing good to say, don't say it, or you just get blocked or deleted. So anyways, moving on from all that, again, thanks to everyone who's subscribed. It's been ridiculous for the last even 12 hours. I think there's been another 400, which is amazing. The views are up, so it spurs me on to do more. So that's the engine in front of you. Crankshaft oiling is the topic, so let's get into it. So in a normal road car engine, the crankshaft is normally oiled by the oil pump, which is standard across all engines. It's oiled by a positive displacement supply with a relief valve, which limits the overall head pressure. So on a Formula 1 engine, compared to your normal car engine, your car engine is oiled into the crankshaft, which hopefully you'll all know what it looks like. It's normally oiled through the big end bearings. So the big end bearings get a drilling down into them. The crankshaft has drillings inside that, and the oil goes from the main bearing section in the crankshaft, and it flows up to the big end bearings, and it lubricates the conrod big end shells. So that's fine in a car engine, but in a Formula 1 engine, because the G-forces are so high within the crank, it has a lubrication system which is called central oiling. Now that gets oiled, number one, to the big end bearings on a remote supply, so they get oiled, but the big end bearings get supplied from a different drilling, which is a drilling which goes into the end of the crankshaft here, in the nose of the crank, and supplies all the big end bearings. So if we just walk through it here for a moment before I bring on the part, which is probably the most amazing part in terms of oiling. So if I just go up here and turn off a load of stuff so that this doesn't crash, Fusion 360, I hope you're listening. So if I turn off the exhaust, we'll have a manageable assembly. If I turn off the timing cover as well, and if I turn on the sump, so let's just turn on the sump. So this is the TJ block, and sump girdle and crankshaft is installed there as well. So just one point to note, as you can see, going back many years to Keith Duckworth, the valve studs are angled, which we'll get to in another video, but if you're thinking that they're not drawn straight, that's how they should be. So that's the engine block there. Just spin it around. The ladder, what I call the ladder sump, is here, and again this will be the takeoff end for the power, and you've got your cylinders there again here. Now if you want to see more detail, maximize the video and pause it and zoom in, take a screenshot, zoom in if you're mechanically inclined. But this is where the various gears will go. These are for that's the oil pump, the water pump is here, crankshaft obviously here, and various other things. So if I split off, which one will I take off? The block. Let me turn off the block. So with the block turned off, you can see the crankshaft. Now again, V10 and shared journals. So we're going to have 5 journals altogether, like that. So you have 1, 2, 3, 4, 5, and they both share 2 cranks, or 2 conrods, sorry. And that is that. So just in case you're not familiar, which I know you are, hopefully, watching this, these would be the main bearings here, mains, PTO there, power takeoff, and this is for your timing chest drive, which drives this is a gear but it's not drawn, which would drive the camshafts all the way up to the camshafts. So again, main. These are the big ends here where they sit side by side, 2 side by side. You can see the drillings there. So they get oiled, each one here, each conrod shell set would get oiled from these. Now the difference with a Formula 1 engine is the mains get drilled or get oiled independently from the big ends. Now because this rotates at 19,000 RPM, the oil, if you were to put oil into here like a car engine and force it out there, let me just zoom in, let's just rotate this to get it on it better. So if you were to put oil in here like a normal car engine, which I think the last normal car engine I saw, I think, was a Volkswagen Golf. So let's just say this is a Golf, or a Rabbit if you're from stateside. So your oil would get injected into one main here, it would flow along the crank and oil the big ends and the mains. But with a Formula 1 engine, the main gets oiled independently. So this would just get oiled, this would just get oiled, this would just get oiled, and so on. And again, these get fed from the nose of the crankshaft, which is hollow with drillings inside. That's mainly done because this oil here has to be forced out here. Keep in mind this crankshaft is spinning at 18,500 or 19,000 RPM, whatever. So once the oil gets pumped out here, it will either get sucked out due to rotational forces, or it wouldn't make it out depending on what angle the crankshaft was at. So it's done independently. So again, this is a dry sump engine. Now I go through, I wanted to keep the oiling of the engine as a separate video, so I just want to concentrate this on the crank, so I don't want to not give too much away, but I don't want to make the video too long by talking about all the oiling in the whole engine. But with this engine, if I just turn on the block, no, actually I'll do a section which will show you the crankshaft. Let's just cut to the crankshaft straight away. So let's do a section analysis on the crankshaft. Don't crash. This is the problem now. See the time you're waiting. Still waiting. There we go. So if I just select this phase, okay, waiting again, waiting. So you can imagine if you were in a meeting trying to present a Formula 1 engine, you don't want to do it in Fusion 360, but let's just wait. So while we're waiting, you can see the longitudinal pens here, which was another DFV takeoff. Again, Keith Duckworth. These are just dowel pins that sit in grooves here, which stops the block, you know, moving this way. It stops the block flexing. So they locate the block and the sump ladder in place. Very simple machine and fairly foolproof. So now we're ready, I think, hopefully. No, we're not. Let's try again. Select the face. There we go. Yes, we're ready. So don't ever use this software if you're under pressure. Actually, let's just cancel that and go for a different cross section, because it will be way clearer. So I just move this over here. So you can see the path the oil takes with the centrally fed crank. So the oil comes in here, these drillings intersect, it goes on, because this is a ground at a different angle, you know, it's got 5 throws, you can't see that, but the oil comes in here, goes off here, goes in here, up to the other one, off to the other one, so it goes through all the way. Now in the actual crankshaft itself, if we take this section, just let me spin it around so that it's somewhat right. And centralize it in your screen and zoom a tiny bit. Come on, where are my arrows? Oh, the arrows aren't there. Okay, Fusion. Right, anyway. So as it looks here, there's another part that's not in this CAD. So the oil will come in here, go across here and off here. Now these drillings are that way because you have to provide access to actually machine them in the first place. So these are actually blocked here and here. So the oil can flow in here but not flow out here. So they're blocked, and so on with the rest of the crankshaft. Now if I do a different section, let's just cancel that. So again, this is where the oil will come out, because we can see it here without rotating it, because it'll probably stall again. So let's just do a section here, and you should hopefully see. Yeah. So there we are. You can see the oil comes out of that where the drillings intersect and oils the big end bearings. So that's how that's done. Now that's not the point of the video. The point of the video is at this end here, which is the business end, and very clever design, which we get to in 1 second. So let me turn on the block again for 1 sec. And turn off the sump. Right. So if I just spin it around this way. Obviously this is a lot easier than using the actual parts because you can see inside them with the CAD. I won't be cutting up these parts to show you the inside because they're just too expensive. Now a section analysis here. So just to show you, now again, if you want to pause this at any point in the video, you can. So you can see again from the timing chest, this is the main oil way along here, along the engine, which feeds the big ends. So that will flow down there into the big end. Again, the machine on this engine, like it's something else. You're probably wondering what these two are for here. It's like a shamrock. These are for other drillings down into the bores underneath the pistons, which are skirt cooling nozzles. They bolt in their drillings there, which I'll show you in the next video because I want to do another oiling video because it'll be just too long. So that's your main oiling channel there. And again, hats off to the machinist. Can you imagine? Like, these would be huge money. If you get, you know, like when you're machining a block, you want to do all your what I would call danger machining first, or what it's called, I don't know, that's what the guys that I know that do aerospace and Formula 1 machining, they call it the danger zones. So you need to do all those first in case you make a total mess of it. Your block is wrote off sooner rather than later. Like, suppose you got these drillings wrong or the bit wandered and you had all the other machining done, you know, it'll be all your time wasted, you know, which would probably 2 weeks or something like that. So you generally do all your dangerous work first in terms of machining an engine or casting, just in case anything goes wrong. Now again, you know, it could fail after you've machined it. If the bit did wander, you wouldn't realise it, and it'll be scrap. But that's generally how it's done. The danger areas first. Now, before we move on to the crank part, which I have underneath the laptop flattened it up, we'll just go back off this section if Fusion would wake up again. Hopefully, come on. So this is probably a great advertisement for a Fusion 360 and why not to buy it if you're drawing something big. So as I said, if they want to reach out to me and provide me with some, there we go, some free elite version, they can, but I'm not really interested, to be honest with you. So right, just to show you a crazy, what I would call a crazy drilling that I wouldn't want to have to do. So again, if we turn on the timing cover, so all your gears live in here, okay? Now there's already a section down there which I don't want to reverse because we'll probably be here until tomorrow night. If I just turn on this again, timing cover, please come on. Yeah. Okay. Right, I do have to turn it off. Sorry, let's just go back. And again, and again, and again, and again, and again. There we are. Right. So, timing cover on. So the pump sits here. The pump in a Formula 1 engine, surprisingly, is nothing. It's nothing different to your normal road car. Again, let's go all the way back to a Volkswagen Golf Mark II, which is the two gears meshing like that. Nothing different. They sit here. There's a filter in the housing they take oil from here, from the tank from here, and it recirculates around and it pumps it in there. So it pumps it into the end of the crankshaft here, and it pumps into this chamber here, which, if I turn off the block, you should be able to see it. So it pumps it up here in that cover, into the block, into the crankshaft, and it also pumps it into the block. Let's just turn off the cover again. Again, pause this if you need to, or if I'm going too quick or too slow. So again, this is the main one here for the main bearings. It's the drilling along, as you've seen. It pumps it down into these two drillings here, and they go into the sump girdle, which pumps it along into other drillings, which I'll show you in 1 second, which are the critical drillings, the crazy drillings. Now, as this goes down here on its way to the sump, the pumped oil, there is a little nozzle here with a tiny little hole, which I'll measure, and which has been measured, which is 0.25 mil in diameter. So the purpose of that hole there and this hole here is it sprays the timing gears at the point of mesh, so they get lubricated from there as well. Again, this drilling, or this boss here, is where the torsion gear damper goes, which you've seen in the other videos. I can't remember what video, number 3, I don't know. So that would sit on there on a needle bearing. The needle bearing then is oiled from this boss here, which there's a cross drilling here through this boss into this drilling on the way down. So it goes in here, across here, intersects into this drilling. So the pumped oil goes in there and then comes out here, out through here, and oils that needle bearing, and also all the holes in the torsion damper. Now, because this is a cross drilling here, if we do a section analysis on it, again, these are all drilled at different angles, so it might come out a bit funky, but hopefully we should see. Again, this is all my own CAD. This isn't belong to Cosworth, so I own all this CAD. I didn't get it from Cosworth Internal Engineering, so it's all mine. So that's why I can share it. I wouldn't be able to share a Cosworth file, obviously, or I'd have many lawyers down on top of me. So if I just go through the section slowly, because this is at an angle, you can see the small hole here intersects that drilling there, which is going down this way, which intersects the drilling which is going down here. So that's how they work. And again, this bung was put in here to stop the oil flowing out this drilling here, and that bung then gets held in with the M4 screw that holds in the truss bearing for the torsion gear. So something else, you know, and took ages to measure and draw. And there's also, on my own file, the proper file, I've got a tolerance file as well, which took nearly twice as long. So there's probably about 10,000 hours in what you see in front of you there. So it's a lot of work for a 45-minute video, but it's just golden to be able to show you, or to be able to be in a position to show you what's going on. So it's just, to me, it's just magic. So if you get something from it, fantastic. So working down from there, these two drillings go down here, and again, let me just have a 1 second glance. Yeah, we're doing good. I will probably actually pause the video now because we're on 29 minutes. So let me cancel that, pause it, turn off the block. We'll get onto the sump and the part in question, which is hiding under the screen. So once that cancels, we'll pause the video. Any minute now. actually I'm just going to pause it, and hopefully we should be back online by the time I'm back online. So I'll chat in a sec. Right, we're back, as is Fusion 360. Anyway, so getting back to just one crazy point in terms of machinist land, which you get a kick out of. So if I turn off the block, which is up here, as again these aren't named because it's a sandbox CAD model, and we lose the crank as well, which was imported, which is down here. We turn on the crank, actually the exhaust is there as well, some of it. Oh, look at that. Right, so the pump also feeds, what is, oh yeah, that's the blocker pin, the blanker pin, which I showed you a moment ago. Let's just turn off that because it's just annoying me. Okay, so the timing cover also feeds down, or the block also feeds down into these two drillings here and here, which go back along through the engine and feed different points. Now one of them feeds, obviously there are two pairs, one of them feeds, just let me turn off that as well because it's going to mess up my orbit. Gone. Right, so one of them feeds these sections here in the casting, which are little machined drillings which spray on cooling oil to the big ends as the crankshaft rotates. Again, this is all very tight in here, there's nothing to spare. I think there's about 2 millimeters between the crank rotation and that face, so it's pretty tight in there. So getting back to these drillings, as mentioned, they feed oil in here and it sprays up onto the crank. Now along here there's a second drilling, which I'll show you in cross section in a moment, onto these areas here, which bolt, there's billet machined cooling nozzles which spray, they're attached on here like this. I'll show you in the next video, and they spray cooling oil up onto the underside of the piston crowns, which cools the crowns underneath. So that's what they are. Now again, they're here on the other side here, because the conrods are staggered on the crank, they're side by side, they need one for each piston obviously, and these are the scavenge ports, which the scavenge pumps suck the oil out of the crank and the air, or out of the what do they call it, the crankcase, and it gets sent back to the tanks. There's 5 of those as well, which we'll get to the next video and get to the point, said you. So let's do a section here. God knows how long this will take. Hopefully it should be swift enough. Let's just rotate that way to get us into the right place and go from there. So if I go back again, these are the drillings here. If I go back through the casting, these will be plugged. So if I just go back through them, you can see the drillings there. So that's the feed drilling is here. So that's the feed. It feeds both drillings, top one and bottom one. Now if I go back more, hopefully it'll break in even numbers. Let me zoom in a bit so that I don't have to start entering data, and scroll back through the crankcase. So you see this, the first one coming up here, which is the cooler jet. Gently. So that's the first one. Let me just grab that. So that's, let me go back a tiny bit more just to get the interface. So you can see what the machinist had to do. So this is the drilling into the top oilway here. So he came in here, or she drilled in there, drilled in this way, opened that oilway to be plural with this to spray the oil in here, and you can just see how close they were here. Again, this CAD model is exact. It's been measured very carefully, both probed on the mill, CMM as mentioned, and micrometer, calipers. It's spot on, you know, within, I don't know, within microns. So there wasn't much to spare there. If we move on, you can see the top drilling then supplies the bottom drilling supplies the piston squirter, which is drilling in here again, down from here, in here, and this is blocked with the plug. The plug would go in here and be swaged in, which blocks that off. So absolutely insane machining. These would probably be flushed, I would say, with abrasive. Like when if you're a machinist, if you were doing this, you'd probably bore down here first, just to have a clean path. Again, these holes are like, I think 2.5 millimeters in diameter, so you know, a bit that length, you know yourself. Normally a drill bit's capability is 5 times the diameter, so these would probably be dream drills or something like that. Again, you drill this and then drill in here the intersection, just so that if you drill this one first, this might wobble when it intersects with this and not meet perfectly. So here there would be, where they intersect, there could be a burr here, so they're probably extrude honed afterwards, like flushed with a corundum solution, which would be a fine grit like cutting compound, just to deburr them or flush out the chips and round these areas here. Now, as I said, I haven't cut the block or the girdle, because it's just like it's priceless, really. It's not priceless, but it's just too high value to go chopping up even a spare one. But this interface here would be very important to get all the breakout chips and the swarf out of. So I would say it's as mentioned, it's pressure extruded, which would be just water with a cutting compound, a deburring compound in it, similar to how you'd cut the paint in your car with T-cut or whatever brand you want. So that's that. Now getting on to the original point of the video, we're gone really off track here. The old timers will be annoyed, and the instant gratification subscribers would be annoyed. Let's just take out the part. I'll turn on the crank again and we'll have a look at the part. The crankshaft was an imported file. So here's the crank. So as mentioned, the crank gets fed in there with oil. Now the huge thing with oil in a Formula 1 engine is not to have air in it. So as the oil collects here, it's been bashed around with the crank, it's full of air. It is deaerated here with a separator, which I'll cover in the next video or whatever video. So the oil is centrifuged out of it, and the air then it gets extruded out of the oil. But just in case some oil makes its way, or some air in the oil makes its way in here, in terms of, you know, there'd be tiny bubbles in suspension in the oil, there's a nose-fed diffuser, what it's called. So let me take it out. Now I'm going to get rid of the laptop in a minute, just so the phone focuses properly. But this is just let me have a look on the video. Yeah, this is the part which screws in there. So when I bought this part, I actually bought this part first before I bought the engine. It had TJ on it, which you can see there on the top. Actually, this is clearer. So you can see TJ wrote it there, or stamped, laser engraved. So I knew it was from the engine. But because I hadn't got the entire engine, I had absolutely no idea where it was from. Now it is heavy, and I was thinking then it must be from the gearbox, but the gearbox is handled by a different supplier, so it had to be from the engine. So I had no idea where it was from. So I eventually figured it out, just by thinking, going back through, as I said, 15 years of experience, and I tracked it down as to be the crank nose oiler diffuser. So let's put away the laptop. Again, if you want to go back through the video, this is filled in here with pressurized oil. That's all you need to know before I get rid of the laptop. It's threaded in here and it feeds into the crank. Now just one more section before I do get rid of the laptop actually. Let's turn off the sump just so that Fusion hopefully doesn't crash. This video is probably a bit longer than I expected, but however, who cares? So let's turn off that sump to lighten up the assembly. And do a section analysis on, is that 90 degrees? That will be. There. Now again, because this is the face that I did the section off isn't exactly at 90 degrees to what I want to show you, but you'll get the idea. So that would thread in there, and this end here would thread into this bore here, which hopefully you can see there. Now this part has a very clever function. Now with all engines, I've noticed that the oilways are done off the CAD or off general engineering calculations, and afterwards the oilways are normally restricted down or restricted up depending on what pressures they see on the dyno or through actual simulation or flow. You know, you could heat this engine up and pump oil through it, pump hot oil through it at 110 degrees, which is often done on test benches I've seen. They'll heat the engine, all the tolerances are then in check, and they can see where the oil is coming out or flowing more than it should or not, or pressures, you can measure them all. So this part here has a restrictor in it. Again, the drillings that fed the main bearings are drilled, I think 5mm, and they're restricted then down to 9mm, or sorry, to 2mm with pushed in inserts with O-rings. So they can restrict them all, you know, after the fact. So this part has a restriction in it, which I shall show you. So this is bored here to, I think, 10mm, and it's restricted then down to 4.8. And you can see there where the restrictor is pushed in, just into the nose. So that's their governor, if you like. Maybe there wasn't enough flow in other parts, or maybe it was flowing too much, but that's a common thing with Formula 1 stuff. Obviously on a mass production engine they wouldn't do that. It'll be just drilled as it should be. They do all the restrictions on the bench, you know, trial it, and then when they go into production, when all their DFM is done, the design to manufacture, they would know what size everything should be, so they can drill them out and do away with the restrictor parts, because part count is important with mass production on passenger cars or whatever. So getting back to this part, screws in there, it's machined down here. I think it was a 16mm hex that's screwed in there. There's an O-ring here, and this is a very, very clever part. So goes in there. If there is, by the off chance, any air in the oil, this will separate it even still. So because oil is more dense than air, the oil will come in here and the air mix. The oil will get flung out by a 5-axis machined diffuser port, which you can hopefully see there. Okay, so you've got your dense oil coming straight out here, and any air then that's in the dense oil, because it's lighter, will tend to stay on the inside of the whirling mass of oil in this fitting, and the air is then pumped out through the center of this, out this hole here, which is really clever. That hole I think measured 0.6, 0.7 mil in diameter, so pretty small. Now there is an o-ring missing off that here. That o-ring was sealing this bore here. Now it's not that awfully clear in the CAD. Sorry, if I just tilt this up a small bit. So that air then would exit in here, up here, and can go out there. So the point of this is that you're getting pure, dense, non-aerated oil into the drillings to lubricate. So hugely clever part. I haven't seen this on the older stuff. Now it probably exists on the new stuff, but again, a steel part. It's heavy, like, you know, it's not titanium. This is aluminium. This would probably be tuned and pressed in just for the tuning of the air size. But like literally all the way, they were trying to prevent air in the oil, which will kill an engine in seconds. I know the Peugeot, the early Peugeot engine, the V10 before this, didn't have this, and I suspect is the reason why they failed quite a lot. So yeah, very clever. A long-winded video on getting to why this part, or the part mentioned in the video, but it's a very integral part in crankshaft oiling, and how you introduce the oil in there into the crank itself with no air in it. Again, last resort part to make sure you've got, you know, dense oil in here, but very clever. So just to recap, the oil would go in here. Because this is spinning so quick at 19,000 RPM, the more dense fluid would stick to the outside. The air, being not so dense, would cling to the middle and get pumped out here in the center. And the oil then, because it's in the perimeter here, you can see the o-rings seals on this seat. The o-ring here will seal there. The oil then can get pumped in this area here and flow to the big ends, and the air will flow at the middle and out here. So very cool. Again, this part I'm going to put up for sale up here. Buy me a coffee link. I've got a few of these, and I've got an on-ran one in my own engine, so I don't need this one. But I think it was a cool thing to cover, and of course all the rest of the stuff we've been talking about. And I think that is it. So next episode, episode 10, hard to believe. Not sure what it's going to be about. Probably go back to episode 8 and just talk a bit about the cylinder head casting around the spark plug area. It's something I want to do before I move on to other parts of the engine. Luckily there's many. So that's it, guys. Again, thanks for watching. Thanks for subscribing. It means a huge amount, and keep the comments coming, unless you're an old timer or prefer to watch Bambi. Good luck, guys.